In this lecture, I'll be talking about some of the statistical foundations necessary for estimating the precision of a sample. Some basic statistical terms that you need to be aware of include what is a variable, which is basically the score of individuals on a particular scale, and a statistic, which is the average of that score across all the individuals in your sample, and a parameter, which is the average scores of everybody in a population. So, if you did a survey and asked everyone to score their happiness on a scale of 1 to 5, any one person's response would be a variable. The average of all the people in your sample would be a statistic, and the average of all the people in the theoretical population would be a parameter. So the next concept I wanted to talk about was the weight of a cow. Well, not really. But here's an interesting story. In the late 1800s, Francis Galton went to a fair in England where there was a cow being auctioned. And he asked a crowd of people who was watching this event to each individually and independently provide an estimate of the weight of the cow. And this is a true story. And what he realized when he plotted the distribution of each and every person's independent estimate was that the overall have a spread along the mean, or it had what is called as a central tendency, and there was a central value around which everybody's answers were spread. This central value is called the mean, the median, or the mode, and the amount of spread from that central property is called the variance. And this is the interesting side note. What Galton stumbled upon was the idea that a crowd of people was fairly intelligent, and in fact, their overall mean estimate was as good as accurate. In other words, people's estimates could vary across the mean. So this would be, the different parts or the different quadrants or spread or the variance of their distributed responses, but their overall responses tended to coalesce, tended to be around a central tendency, which was the accurate mean. Okay, this is a very important idea, and this idea is central to statistical techniques. This is called the normal distribution. So the normal distribution is a symmetric single-peaked bell-shaped density curve. And what the curve has is a mean or a central tendency, and it has the overall variance that is broken up into smaller subparts called the standard deviation. The mean determines, or rather the standard deviation determines the shape of the curve. In other words, the spread of the curve, right? The more standard deviation units you go away from the mean, the more spread there is to the people's individual responses, or what we call collectively as the variance. So this concept of normal distribution is important. Normal distribution has certain properties. In all normal distribution, 68% of the observations fall within one standard deviation of the mean, which means you take the mean in the center, one standard deviation to the left, one standard deviation to the right. In other words, one standard deviation plus one minus one together, 68% of everybody's responses tended to fall, or tended in the Francis Galton case, fall within those one standard deviation. 95% of everybody's guesses fell within two standard deviations, and 99% fell within three standard deviations. So what the standard deviation does is it tells us how far or near most people are to the mean or the average, right? In other words, it is the collective variance of the group. So if you just add all of them, it gives you the collective variance. So supposing now we take that example, and instead of having people guess the weight of a cow, we do a census of all New York City residents. So mind you, this is a census, and what that means is we go to every one of the 8.5 million people who live in New York, and we ask them how happy they are. And we ask them, hey, how happy are you today on a scale of 1 to 5? So let's just, go with this thought concept. And we get a mean, right? So we get a mean between 1 to 5. Let's say most people are on average a little happy, not really unhappy. So, a little bit above average, 3.75. And we get a standard deviation of 0.25, all right? These are just made up numbers. So what does that tell us? What we understand by this is that the center, the mean of the population, is about 3.75. One standard deviation to the right is 0.25. One standard deviation on either direction would be 3.75 plus 0.25 or 3.75 minus 0.25. So 68% of the cases will fall between 3.5 and 4. 95% would fall within 2 standard deviations from the mean, and 99% would fall within 3. Okay, this is the concept of the normal distribution that is very important to understand. The normal distribution is a property of large numbers. What that means is if you have a lot of observations, what you end up when you plot those observations is a normal distribution. Okay, and that's a law. That's almost a law which you need to understand. It's a property of large numbers with enough observations. In other words, with enough responses, with enough people giving you a guess or giving you a response to a survey, giving you, let's say, the answer to a question, what you would end up with is a distribution that looks relatively normal. You can take the Francis Galton example and think about it that way. You can think about another example. Let's say, you go to a large class, one-on-one class, and ask everybody their age in months. Some people are going to over-report it, some people are going to under-report it, some people are going to not remember, some people are going to add a few because their math is not that good, some people are going to subtract a few. But in general, when you plot that distribution, what you would get is that most people's age in COM 101 would coalesce along a center, whatever that number may be, maybe whatever that mean age of that class is in months. And then you would have the number of standard deviations on either side. Okay, so going back to our example, so we did a poll of everybody in New York City, 8.5 million people, right? And we got this distribution. But the problem in the real world is that we cannot do a poll of everybody, because by the time we do it, one, we're broke, and two, people's happiness levels have varied, right? Because it may take weeks or months to do this study. So what we end up usually doing, rather than doing a census is a study where we study everybody, is we do a sample-based study, right? This is what we all do. We do sample-based studies. And let's say for our example, rather than doing a census, we do a sample-based study of 100 people, right? These are 100 people who we can easily access randomly in New York City, and I ask each of them that same poll question, right? And we get an average happiness level. Okay, now this average happiness level, again made up numbers, 3.75, standard deviation of 0.25, comes from a sample of 100. The question that we always try to answer in any study is how well does this 3.74 represent the response of 8.5 million people? In other words, if I had done this study as a census rather than a sample, would I get the same numbers? Okay, how do I know I can rely on this data? Okay, what would have happened, let's say, if instead of 100 people, I used 2,500 people? I had a little bit more budget or time. To answer these questions, we have to understand. To answer this question, you need to first understand the concept of a sampling distribution. So,